All right, the next part seems to be the hardest for students to grasp, so make sure that you pay close attention. Okay, so this is where I was talking about. You have an open circle. It looks like the word fog. If it's f composed of g, that's what you say. So f composed of g of x, or you can say f of g of x. And it's the domain is the set of all x in the domain of G such that G is in the domain of F. Okay? So, what does that look like? Okay, for my brain to comprehend what the heck is going on, I have to write it as F of G of X. So follow the order, F and then G. Notice that the next problem is the other order. Then, okay, so inside my parentheses, I have G of X. Well, according to my example here, G of X is equal to 1 over X minus 3. Okay, bring everything else down. Okay, so I didn't do anything with the F yet. I haven't done anything with the parentheses, but I did replace G of X with what it equals. Okay, then notice that F of X equals X squared plus 1, and I have the F function now. So what I like to do is think, all right, so the F function is X squared plus 1. Where there's an X, I'm just going to put parentheses. So blank squared plus 1. And in those parentheses, I'm going to put what's in the line above. So in this case, 1 over X minus 3, quantity squared. Okay. And when I think about what can my domain not be, I feel like it's easier to think about what it cannot be instead of what it can be. Well, it cannot be something that makes the denominator of a fraction 0. So X cannot equal 3. If I want to write that in interval notation, in order to say everything but 3, it becomes a little bit longer, which I think is a little tedious. So think about it. You got all the numbers that are less than 3, so I'll write that as negative infinity to 3. Make sure it's a parenthesis because that does not include it. I have this little union symbol that just means like and, both of the pieces. So this piece and the next piece, union. It can't be 3, but it can be the number right after 3. So it could be something like 3.01 and then forever. Okay. What about if I go the other way? So G of F of X, just like subtraction and division. Order does matter because now, remember, F of X equals X squared plus 1. So now when I look at my G function, where there was an X, I am now going to replace it with X squared plus 1 because that is what is in the parenthesis above. All right. Clean that up a bit. I get 1 over X squared minus 2. So what can X not be? So maybe we solve the equation. X squared minus 2 cannot equal 0 because I cannot have 0 in the denominator. So that means X squared cannot equal 2. So X cannot equal, because I'm going to take the square root of both sides, positive or negative square root of 2. Okay, so one way to write that is just simply that. X cannot equal positive or negative square root of 2. If we think about that on a number line, we have the space from negative infinity up until negative square root of 2. Then we have the space in between the square roots, so from negative square root of 2 to square root of 2. And then we have the positive space of square root of 2 to infinity. All right. So if you think you have the idea of what composition is, you are welcome to pause here or skip to the end and check your answers to make sure they are correct. I do encourage you to actually try these problems, so maybe press pause and write them down. Let's scroll up a little bit so that we remember what F, G, and H are. So now is the time to hit pause to write those down and try. And I will keep on working from here. So next problem is F of H of X. So H of X is just the square root of X. So where there was an X, I'm now going to put a square root of X in the function of F. Remember, a square root and a squared cancel each other. So here, I just have X plus 1. Notice, X can be anything here, but it kind of gets tricky because I also have to think about right here. Would that have been okay if it was negative? No, X originally had to be a positive number in order to be a real number. So it had to be greater than or equal to 0. All right. Do the reverse, H of F of X. So remember, F of X was X squared plus 1. H was just square root. All right, so this one's going to take a little bit of logic to think through. Remember, no matter what X is, when I square it, it becomes positive. So if X was negative, once I square it, it's positive. If X was 0 and I squared it, it's 0. So 0 plus 1, that's still positive. I'm good. No matter what number I plug in for X, I'm going to get a positive number. So the domain is everything. All right, next weird one. Composed within itself. So G of X. G of X is 1 over X minus 3. Plug that in where there's an X on the function. And then there's some simplification stuff that happens, and I'm realizing that you guys did not get deep into rationals. So we're going to put the true answer to that one on pause until we cover that lesson. So keep on going, we're good. And then this one's 3. So F of G of H of X. So H of X was square root of X. And then if I plug that in for G, I get 1 over square root of X minus 3. And then I plug that in for F. F was X squared plus 1. So that whole thing squared plus 1. 1 squared is 1. The bottom, we're not even going to worry about more than just putting the squared down there with it. All right, so for the domain, remember the bottom cannot equal 0. So the square root of X minus 3. Quantity squared cannot equal 0. So if I take the square root of both sides, I get square root of X minus 3 cannot equal 0. So the square root of X cannot equal 3, not 0, sorry. So X cannot equal 9. So the way, so I can either say X does not equal 9, or there's also a different stipulation that we got to think about. We do have a square root. I cannot have a negative under the square root. So it also has to be greater than or equal to 0. So 0 is my starting place. It can go up to 9, but can't be the number 9. But it can be any number after 9 forever. So notice we will hit domain and range off.